probably not named Jimmy, being where he is from.
Justin.
Don't meet a lot of Jimmys in India, I don't think.
Jimmy Two Shoes.
Tirath.
Yeah.
Now, Tirath, you are the first Tirath I have ever met. True story. All right. Jazzcarn, you are not the first Jazzcarn I've met. When I was in grade 10, I had a buddy named Jazzcarn.
Wait.
He went by Carney, though.
Wait, is this the first Chima you've ever met? Probably my brother.
What?
Is this the first Chima?
I've known lots of Chimas.
Oh, okay.
I don't know if I taught your brother Harsharan. Yeah. Oh, Harsharan. Oh, but she saved it there.
I was off the pencil.
Takanari. All right. And Sophia. All right. And Charlotte. All right. Hear it. What? Yeah, I know. I gave you some credit.
Yeah, you're here.
I know.
Yeah.
I'm well aware of that. All right. Let's go. Okay. Let's start with Sartaj. What's number 1, Sartaj? Pardon me? F is absolutely correct. Correct. What an idiot. Correct. Yeah, that's called a portmanteau. It's a word in English. When you take two words and you make one word out of them, it's called a portmanteau. Correct is a portmanteau. That's when you're extra correct or more right. All right. Sahil, hit me. What's 2? Pardon? E? All right. And Vikram, hit me. A. You know what's funny? That you guys still laugh at that. When I say hit me. Hit me. Hit me. Hit me. Hit me. One more time. Hit me. Woo, doggy. Hit me. Okay. Trinity, number 4. Just look at your page, Trinity. What letter did you write by 4? If it's wrong, you're just going to put an X by it. H is the right answer. Number 5, Amrit. C as in Cucamonga. That's absolutely right. Harsharan, do you have 6? E? Process of writing a number. Nope. G. And number 7, who'd I get to? Jazz. B. Yeah, brother. Well done. Give yourself a mark out of 7. Tirath. Yes. Jimmy Brar. E. Yes. 10. Sophia. A. Oh, he's on fire. Charlotte. C as in F, because 1 and a radical, we don't write the 1, right? So that would be a whole radical. Tricky, I know, kind of a dick move on my part. Prussia, 12. C, And 13, Sandeep. D, irrational number. And 14, Jeshan. Pardon me? B, yeah. I would accept that. That's absolutely right. Give yourself a mark out of, oh, look at that, 7. Now, down here, there's a few different answers you could have, right? So, Isha, what you got? Add. Now, some of you will have written that symbol. Some of you, who I will make fun of, will write plus the exponents. Because that's what we say, right? We plus them. What did you do? We minus them. What did you do? We times them. Something like that, you get the mark. Erlen. Multiply. Well done. And number 3, Avian. Any non-zero base raised to the exponent of 0 equals 1. Well done. Give yourself a mark out of 3. Making the whole first page out of 17. Any questions? Going once. Going twice. Going thrice. Gone diddly on. What do we get up to here? Number 5. Oh, number 4. Number 4, the number's missing. Is the number missing on yours too? No. Weird. What did we get to? We got to the back. Jasmine, go. Reciprocal, yeah. I would also accept flip. I will not accept opposite. Why? Opposite means positive and negative. It does not mean anything to do with flipping them over. 5. Who are we at? Garlene. 2 root of 15. Absolutely correct. 6. Loveline. I think you might have read the question wrong. As a power of 4. That means 4 is the base. Because the exponent tells me what power we're going to. How many 4s do I have to go to get to 1024? 5 of them. 4 to the 5th. Edge length. Muskan. 7. Yeah. Number 8. Indeed. It's a toughie. It's the toughest one on here, I think. What does x have to equal? Ooh. It does have to equal 3. That has to be negative 3, so it flips the fraction over. Yeah, but he wrote it, so really. Knock yourself out, buddy. Number 9, Sale. No. If there's 1 3 out there and that's a 4, how many 3s are under there? Root 405. Is that what you said?
I said 405 squared.
Oh, yeah. It's the 4th root of 405. And finally, number 10. Hear it? Oh, just that one. What are the chances? That sucks that I've asked 25 questions and I get to the one that you haven't done. What are the chances of that? Hey, Sevik, you're laughing pretty hard. You got that one done? Oh, you probably shouldn't be laughing at Kirit then, hey? This is m to the 2/3 over n. And that part's out of 10. Evaluate this using prime factorization. So that means break it down. What is it? I don't want to go person by person now. Somebody give me an answer. Pardon me? $98. Not times 98. So the square root of 9604 is what? 98. So it's done. But you had to use prime factorization. Which means we didn't eat them. But I hear they're delicious. Have any of you had guinea pig? No? It's funny because they cook them and they look just like guinea pigs. Yeah. If we have some time, I'll show you. All right. So remember, if I ask you to do this on a test and you only say 98, am I giving you full marks? Am I giving you any marks? No. Because the question says evaluate that using prime factorization. Right? If I have enough bananas, I can teach a monkey to get the square root of that on a calculator. Does that mean the monkey knows how to find the square root? No.
For 410, how did you get n2 over 3 and n?
Because that is m squared over n cubed to the 1/3.
Okay.
2 times 1/3 is m to the 2/3. 1/3 times 3 times 1/3 is n to the 1. Cool? Okay. 98. That's worth 1. Actually, that should be worth 2 marks because you had to do prime factorization. Write and evaluate an expression using exponents for the total area. So that's 5.1 squared plus 3.5 squared to equal whatever it equals. It's going to be about 25 and 10. It's going to be about 35. I really don't care what it is. This is the important part. This is 4.3 squared plus 9.3 squared, which will be somewhere in the neighborhood of 18 and 95, somewhere in the neighborhood of 113. Again, this is the important part. You get 1 mark for each of them. Whoo, doggy! Some of you will have taken this too and put it to everything in the brackets. Some of you will have simplified this and then brought that in. Do I care which order you do this in? No. Which order do you think I would do this in? Simplify first. Why? Because you simplify every chance you get. Because the word simplify means make simpler. So this is a to the 3rd, b to the 4th, c to the 6th, all squared over b to the 6th, c to the 15th. Then the 2 goes in, a to the 6th, b to the 8th, c to the 12th, over b to the 6th, c to the 15th. A's don't change, so it's a to the 6th, not 9 to the 6th, a to the 6th. 8 minus 6 is b squared. 12 minus 15 is c with the 3 down there. That's the final answer, and it's worth 2 marks. I am going to treat myself to a piece of sushi because that was a lot of work. Little soy sauce, little ginger, little wasabi. Good eating.
Eat the whole thing with wasabi.
No, because that's stupid. Just like eating a teaspoonful of cinnamon is stupid. Just like dumping ice water on you to say you did the ice water challenge is stupid. Just like wasting your time watching videos of Lil Tay is stupid. Just like watching Fail Army 2018 is stupid. Should I go on? If Lil Tay was my daughter, imagine what she would look like then. And I can say this honestly because I actually have a moderately famous son. My son is on the 100. No. Maybe. All right. As long as you put these from biggest to smallest, I don't care how you did it. That's why I said describe the method you use. So some of you will have used your calculator and got decimals. That's cool. Then put them in order. Some of you will have put them all to whole radicals. Now, some kids read this as saying 2 cubed and then root 5. Some kids read this as 2 cube root 5. So there's really 2 answers here, depending on how you read that. Nobody asked me about it. So if you read this as 2 cubed root 5, then that's 8 root 5, right? How many people read it that way? No one? That's the first. Oh, a couple of you did. Okay. So if that's 8 root 5, then this is the root of 64 times 5, right? Which is 320. And then this is root 30, and then this is root 64, and this is root 54. So greatest to least, this is the first one, that's the greatest. Then this is the second one, then this is the third one, and then that's the fourth one. If you read that as 2 cubed root 5. If you read it as 2 cube root 5, then this is the cube root of 40, root 30, root 64, and root 54. Now the cube root of 40, you know, is between 3 and 4, right? So it's 3 point blah. The square root of 30, you know, is 5 point blah. The square root of 64 is 8, and the square root of 54, you know, is 7 point blah. So in order of greatest to least, that's 1, then that, then that, then that. All right? Now, I can't prove it, but if I ever ask you a question like this on a test and I say describe the method, if you don't have a description, even if you have the right answer, I'm only giving you half marks. Understand? So, put them in order and then use your method. Whatever it was, it's out of 2. These are out of 1 each. 3 root 5, 2 cube root 5, and 243, I can't remember, 381, 9 root 3. For 1 mark each. Down here, express each radical as power 3 to the 5/4 for 1, x to the 4th over y to the 3, all to the 1/2. I give you half marks for that, but to get the full mark, it's x squared over y to the 3/2. And this one is 64n. Now, 64n to the 4th, all to the 1/3, which I would accept. Better is 8n to the 4/3. But I will give a full mark for even that. Questions? Everybody good? That's out of 3. The dice rolling game. It depends on what you mean when you count rolls. Right? If you're counting everybody rolling the dice, then that's 1 roll when everybody rolls. So there's 8. How many are left after everybody rolls? 4. So 1 roll takes us down to 4. How many are left after the second roll? 2. That takes us down to that. And how many are left? 1. So you need to have 3 rolls and you've got a winner. Or you could say there's 8 people rolling the dice. So that's 8 rolls, then 4 rolls, then 2 rolls. So some people say the answer to this is 14. I don't care how you counted it, as long as you can explain it. Do you understand what I'm saying? If you said 71, obviously you don't understand the question in any way. Everybody cool? out of 1. Making that page out of 7, and 2 is 9. And the previous page was out of 7, 9, 10, 11, 13. Out of 13, 2, 5, 8, out of 9. And the last page. You get 1 for her error. What was her error? She added the exponents. What should she have done there? Subtracted. So that's her mistake. She added. Dadoy, to quote Brooklyn Nine-Nine. The correct solution is 3 to the negative 0.25 plus 0.75, which is 3 to the 0.5, which is 3 to the 1/2, which is the square root of 3. Out of 2 there, making the last page out of 3. Making the whole thing out of 3 and 9 is 12, and 13 is 25, and 17 is 42. Give yourself a mark out of 42. When do I find out what you got on this? On Monday's unit test. How will I find out? You'll write it on there. Will I find everybody's? No, because a bunch of you, even though I'm saying this now and will remind you on Monday, still won't write your score. Which I find very funny. You're willing to throw away 42 marks by not writing it down, but if I miss a half mark on your test, I got to line up out the door. Can I get a half mark here? Any questions? Sweet. All right. On Monday, third block, we will be having a test on this stuff. Please open your books to page 119. Polynomial multiplication. All of you, grade 9s and 10s, should be able to do this first lesson without me at all. But let's just make sure. A polynomial is an expression. Now this is a problem here. How many people understand what the word expression means in math as opposed to an equation? What's the difference, Zach?
Expression doesn't have an equal.
An expression has no equal sign. X plus 3 is an expression. Is there an answer to that? Yes or no? Is there an answer? No, there isn't. There is no more math to be done there. That is done. You cannot go further. Everybody with me? X plus 3 equals 10. Now, could you do math? Now, could you tell me an answer? Yes. All right. So in this whole unit, you will almost never see an equal sign. So you will almost never be writing an answer. What you will be doing is simplifying to the simplest possible terms. Does everybody understand that? Okay. So a polynomial is an expression made up of coefficients, variables, and constants. Now, some of you know what those words mean. Some of you may have forgotten. Coefficients and variables we've already talked about, right? We already know what those are. Constant is just a number. All right? So, red are coefficients, 3. Blue are variables, q. Green are constants, plus 7. That's a polynomial. Everybody good? What's the answer to that polynomial? It doesn't have one because there's no equal sign. Is everybody good? There are some rules about polynomials. 1, exponents must be positive. 2, no irrationals. And there's a couple of other rules, but for our intents and purposes, that's enough. Everybody good? Yeah, right. A monomial. Mono means 1. So a monomial is 1 term. So it's either a variable or a constant or a coefficient times a variable. X, monomial, 1 thing. 7, constant, 1 thing. 3, J. Somebody always says, well, Mr. Myers, that's 2 things. But it isn't, is it? Because once you know what J is, then what is this? It's 1 thing. Does everybody understand? If J is 7, then this is 21. That's 1 thing. Got it? Okay. A binomial, just like a bicycle, is 2 terms. So what that means is it's a monomial plus or minus another monomial. What's the difference? If there's a plus or a minus, you have at least a binomial. X plus 7. 3j plus 9. 4xyz plus 3abc. Still a binomial because xyz has no pluses and minuses between them. Everybody good? And finally, dodoi. A trinomial must be 3 terms, which means it's mono plus or minus mono plus or minus mono. Yeah? 3x squared plus 2y minus 4. Everybody good? How important is this? Not at all. Yeah? Okay. Degree. The degree of polynomials is only important because math people have agreed on how they write polynomials, in what order they write them. So it's not important at all to doing the work. Does everybody understand that? So I'm only going to show you once. I don't even think it's on one of my tests. The degree of polynomials is I'm going to change that to a totally different color because it's completely weird, is the sum. I'm going to change sum, sorry. Is the greatest sum of the exponents of the variables in any one term. Okay? I'm going to slide over here to show you examples because this doesn't matter. 3x plus 7. What's the exponent in that term? That's the variable. It's got an exponent of 1, so that is a 1 degree polynomial. Everybody got it? So what would this one be? 3x squared plus 7. What's that? A second degree polynomial. 3x squared plus 3y. What's that? No. The greatest sum of the exponents of the variables in any one term. This is still 2. Because that guy has the biggest. Everybody with me? Now here's where it messes kids up. 3xyz plus 4a squared. What's that guy's degree? 3. Because this is 1, 1, 1. That's 3. That's only 2. Is everybody good? I don't even care. I just need you to see it. And this is the rule for writing them. What does it mean? You put alphabetical by degree. So the closest to the beginning of the alphabet and the highest degree goes first. And then you finish that letter. Then you start on the next one. Do I care? Do you think? If you write out all the terms and they're all right, they're just in the wrong order, am I giving you full marks? Yes. So don't even worry about this. I just want you to see it because you may have an old school math teacher in grade 11 who says, write it in the right order. Okay? If you are in my class in grade 11, I won't be doing it then either. Right? Now, next thing. I hate algebra tiles. They have one use and one use only. And you can do that use for them in the 5th grade. I do not like them because they are only good up to an exponent of 2. Are there exponents higher than 2? Yes, so algebra tiles are completely useless for every single other exponent except squared. Now, since numbers go up to infinity, algebra tiles are good for exactly 1 out of infinity possibilities. So I don't like them, but I'm told you guys have to understand them. So I'm going to draw them 3 times. If you don't get them, you might lose 3 marks. Everybody got it? And I'm not going to spend a lot of time on them explaining what they are. What algebra tiles are is they are a concrete example of variables, right? The reason we have them is because some people don't understand x squared, and 1. And algebra becomes difficult for them because they don't see the numbers. So some very smart person invented this. The problem with it is if you understand the numbers, then algebra tiles are complicated. My wife still hates them. She doesn't really understand them. But whatever. So, this is how they work. There's a little tiny square, and there's a little tiny shaded in square. In math, everything is either what? Positive or negative. That's what this is. That is positive 1. That is negative 1. This is how we use algebra tiles. If I wanted to do 3 plus 2, 3 is positive. 1, 2, 3, 1, 2, 1, 2, 3, 4, 5. So the answer is 5. Got it? That's how easy it is. If you haven't seen them before and you're seeing them for the first time, great. Here is the only thing that I like using them for. And some of you may want to pay attention to this. 3 minus 4. Draw this out. 1, 2, 3. There's 3 positives, yes? What action does the word minus make me do? Take away, right? So this sentence says, start with 3 and then take away negative 4. Do you see any negatives here for me to take away? There's none. There's only these three positives, correct? So, what if I do this? How much is negative 1 plus positive 1? Negative 1 and positive 1 are what? 0. There's 0 again, yes? There's 0 again, yes? And there's 0 again, yes? So what do I have there? I have my original 3, and I've added 4 zeros, correct? What is 3 plus 0 plus 0 plus 0 plus 0? 3. But now, do you see 4 negatives there? Now can I take them away? 1, 2, 3, 4, 5, 6, 7. That's why algebra tiles work. That's why subtracting a negative is the same as adding. It's not because 2 negatives make a plus. Okay? That is why. Does everybody understand? That, for me, is the only real use of algebra tiles. The only real use. Sometimes it helps kids as well. Now, I have this monomial times a binomial, right? Because 5 is a single thing and x plus 1 is 2. So, what is this saying to me in English? Read this to me. What would you say? 5 times x plus 1, correct? So, if I was going to draw it, I know what 1 looks like, but I don't know what x looks like. X is this. It's a straight bar. And it's about 5 of these things, but it's not exactly 5. So in math, if I don't know an exact value, what do I give it? A variable. That's why this is x, which makes this negative x. Then, if I take that bar as a length and I spread it out by that width, I get x by x, which makes this x squared. And that is negative x squared. And then algebra tiles are useless because you can't go any further. So what does this mean? This is saying 5 times x plus 1. So how would I draw x plus 1? There's an x, there's a 1. Agreed? And how many times do I got to draw it? 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Now, this side has 1, 2, 3, 4, 5, right? 5. What does this side have? X plus 1. There is my x plus 1. This is my answer, which is 5x plus 5. Right? You've all seen this before. If you haven't seen it before, I apologize. But I got to show you. It's shown now. Now, let's talk about what's actually happening. Algebraically, this is what I want. 5x plus 1 equals, what math is happening right there? Multiply. So that's 5x plus, if that wasn't there, what would this be? 5 times 1. 5 times x is 5x, plus 5 times 1 is 5. This, x times a plus x times b, this is called the distributive property. Because that coefficient is distributed into this polynomial. Now, every teacher has a cute little name for this. Everyone. Some teachers call it flying arrows. Some people say it's a little bunny hopping into its holes. Some people tell all these cute little stories about it. Do you know what I call it? the distributive property, because that's its name. If you need cute little stories, go back to kindergarten. Okay? Now, the distributive property, everybody is like, oh my God, I don't get it. Is there anybody in here that is in the, oh my God, I don't get it spot? What if I told you this? X times A plus B plus C. What would the answer be? XA plus XB plus XC. What if it was negative X, A plus B minus C? What would it be? Negative XA, negative XB, positive XC. Can everybody do distribution? If you're bad at it, draw the arrows, write the answer. Everybody cool? Distributive property, we have it right here, right? You already know what it is. The coefficient outside the brackets multiplies by every term inside the brackets. Where inside the bracket? Inside the brackets. Where are you going to mistake? Watch out for positive and negative signs. Okay? Show a picture and an algebra for this. All right. Picture means tiles. Now, what is this saying to me in English? X times 2x minus 4, yes? Right? Now, there's only two factors there, so the way they teach this is a length and this is a width. And we make a rectangle. The length is x. How do I draw the length of x? X. There's only one x. How do I draw 2x minus 4? How do I draw two x's? X, x. And how do I draw minus 4? Four little guys, right? Now I've got a rectangle. Length and width. Where's the area? Inside. There's this x, but it spreads out that far. So it's that. Everybody with me? Then it happens again. And then what wins? Negative or positive? Negative wins. So I have a negative, a negative, a negative, a negative. And the answer lives in the middle. X squared, and then another x squared. 2x squareds. 1, 2, 3, 4, all negative, negative 4x. Does everybody understand algebra tiles? Good. Now do it the better way. X, 2x minus 4, that equals 2x, that equals x times 2x minus x times 4. 2x times x, 2x squared, minus 4 times x, 4x. Is everybody good with pictures and numbers? Going once, going twice, going thrice. Good, prove it. Do it right there. Pictures on one side, numbers on the other. Go. Having some trouble with that, carrot? It's covered in grease or something, just keeps jumping out of your hand? That's the worst. Everybody should have been able to do that. Yes? All right. Honestly now, everyone could do this, yes? Okay. Every one of you, including the grade 9s, should already have seen this. Right? Some of you grade 9s will not have seen this. Grade 10s all will have. So, we're going to show, again, as always, we're going to do a picture so I have covered myself. This says x plus 3 times x plus 2. There's a length, there's a width. Draw the rectangle. How do I draw the length? X plus 2, x plus 2. How do I draw the width? X plus 3. And then I fill it in. Big X squared, x, 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 x. 1, 2, 3, 4, 5, 6. Answer is in the middle. X squared plus 5x plus 6. Is everybody good? It's the exact same thing, right? I just took the first one, put it on one side, took the second one, put it on the other side, and then filled in the middle. Does everybody get it? All right, now we're going to get a little tricky. What we're about to do is very, very, very mathematically important. Okay? Algebraically, x plus 3, x plus 2. Now, let's pretend the x wasn't, or the 3 wasn't there. What would you do for that? That would be x squared plus 2x. Agreed? Now let's pretend the x isn't there. What would you do for that? 3x plus 6, correct? Well, I've already got an x, so I'm going to go ahead and put my 3x's with my other x's, because x's go with x's, yes? And then 3 plus 2 is what? 6. And then I just add it up. X squared plus 5x plus 6. 0 plus 6, x squared plus 0. Does everyone see that? Everyone sees that? And what did I do? With the green line, I did x and x. I distributed the x. Then with the red line, I distributed the 3. Which means I did double distribution, correct? If you have a math teacher from grade 9 that showed you this, you've already seen it. If you had a math teacher in grade 10, you've already seen it. That math teacher in grade 10 probably gave you this acronym, FOIL, which stands for first, outside, inside, and last. Now, here's the problem with learning the word FOIL. When does it work? When I have 4 things, right? Is it possible that I might have more than 2 terms in either one of these binomial or polynomials? It's possible, isn't it? Because we know that trinomials at least exist. FOIL works wonderfully for binomial times binomial. But it doesn't work for anything else. So I don't like to talk about it a whole lot. But what it is this. And I'm going to write it out with all letters. So first, I'm going to do that with the red line. X times x, and I get x squared. Then with the blue line, I'm going to do outsides. That is outside because it's on the left, it's on the edge. That is outside. So it's plus bx. Everyone see? Next, with the green line, inside. A and x. Now, because I've already got a single x, I'm going to group my x's together. And then last, I'm going to do with the gray line, that's plus a times b. Again, we call it FOIL. It works wonderfully for binomial, but nothing else. What actually works all the time is the distributive property. And here is what I mean by that. First, I want you guys to do this for me. Set it up with FOIL. What is my first product going to be? X squared. What's my next product going to be? Plus 4x. What's my third product going to be? Negative 1x, and I keep my x's together. And my fourth product? Negative 4. And then I put it all together. X squared plus 3x minus 4. Everybody can do it, right? Okay. Here's the problem. Does FOIL work for this? No, because there is more than insides, outsides, and lasts, aren't there? But does the actual work we're doing work here? The x goes once, twice, thrice, which gets me what? What is the first one? X cubed plus 3x squared plus 4x. Now I'm done with this guy. What's this one? 2x squared. Do I already have some x squareds? So I'm going to keep them together. 2x squared. What's this one? Plus 6x. I've got x's, so I'm going to keep the x's together. And what's this one? 8. Then I just put it all together. X cubed, 3 plus 2, plus 5x squared, plus 10x plus 8. If you stack them like this, it's impossible to do it wrong. What if I had a third one out front? Then what would I have down here? If I had a third term out front, I'd just have a third line stacked here, wouldn't I? Then I would just add them. Is everybody cool? You're going to get tons of practice doing it, so don't worry if you're a little off right now. Now, woo! You all saw it, right? It was written there. Okay. Does everybody understand FOIL? Everybody? Okay, I'm going to give you a present right now. What? For the second one, you what? Yeah? You skip one out because these are like terms, x squared and x squared. Okay? Everybody good? All right. Now, as I just said, I'm going to give you a present. Some of you already know this trick, so be nice to those of you that don't. What do you notice about what's highlighted in yellow? What do you notice? Those two numbers that are highlighted in yellow, how do they relate to that that's highlighted in yellow? 3 plus 2 is 5, right? What do you notice about what's highlighted in green? 3 times 2 is 6. Does everyone see the shortcut? If you start with a single number and another single variable, then you can do this trick. The middle term is plus, the last term is multiply. So just to help you out, and it only works then. A plus 4, A plus 3. What's the answer going to be? Does it start with a single letter? So can I do the shortcut? It's going to be A squared plus 7A plus 12. What if it was M minus 3 and M plus 5? Then what would it be? M squared plus 2M minus 15. Everybody see the little trick? When does it work? Only when it's a single letter. So will that trick work with 2M plus 5 and M minus 3? Can I do the trick? No, I must use FOIL. Or the better name for it, distribution. Is everybody good? Spectacular. You have 20 minutes. I want page 122 and 123 done in 20 minutes. Go. I will be marking your cumulative exams. So far, I have marked 4, and I am moderately happy. If people don't ask me questions like, do you think you're going to get done by the end of the day and waste my time? Yes, I will get done by the end of the day. Because you can only spend each minute once, and now I spend a minute that I could have been marking talking to you. Right? Right. Well, of course you can. You don't have to sign in. Girls aren't destroying the bathroom. All right. You have had your 20 minutes. So, you all should have all of these written down on page, from page 10 or 123 and 124, whatever the heck it is. Sir, let's get that out of the way. 1, 2, 3, 4. 1, 2, 3. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8. 12x squared minus 8x. X minus 1. X minus 5. X squared. 1, 2, 3, 4, 5. 6. 1, 2, 3, 4, 5. X squared minus 6x plus 5. You know, I especially like you guys, because whenever I do math, you're laughing, because math is so comedic. I get it, right? If I was getting your scores, I'd laugh too. Huh? I know it was. That's why I said it. Okay? I don't say things that aren't worth saying. Okay, what's this answer? 4x squared minus 16. What's this one? X squared plus 4x plus 4. What's this one? What's this one? Plus 13? x minus 6. What's this one? X squared plus 2x minus 63. X squared plus 13x plus 36. X squared minus 6x plus 8. Now, make sure you have all of them right. I guarantee a whole bunch of you for this one wrote x squared plus 4. I know you did because I've taught math for 20 years. What's the base there? X plus 2. What does the exponent? Which means if there's an exponent of 2, how many bases do you need? 2. The base is x plus 2, and then you need it again. X times x, x squared. 2x and 2x, 4x, 2 is 4. It does not distribute in because this is not a single base. Aight? Which means everybody who did B wrong is going to have done the last one on this page wrong, but we'll come to that in a minute. X minus 2, x minus 1, x squared, minus 1, minus 2, minus 3, 1, 2, x squared minus 3x plus 2. 8x squared minus 6x cubed. Is that in technically the right order? No, because the 3 should be first, shouldn't it? So this should technically be negative 6x cubed plus 8x squared. Do I care? No. This one is 8x squared plus 10x minus 12x minus 15. Added up, 8x squared minus 2x minus 15. That's the answer. This one, x squared minus 4y squared. This one, x squared minus 8x plus 16. Everybody knows y now, correct? Why? Because there's 2 bases, and the base is x minus 4. X minus 4 squared. Okay, now it gets tricky. Because we got to distribute 6 times, yes? The first one, I'll draw in black. 2y squared minus 8y plus 2. Is everybody okay with that? Then I'll do this one in red. Negative y cubed. Are there any y cubes here? So I'm going to write that off by itself. Minus y cubed. Minus y times minus 4 is plus 4y squared. And I put the squareds together. Minus y times 1 is minus y. And I keep the y's together. Then I add them up. Negative y cubed, 2 plus 4, positive 6y squared, negative 8 and negative 1, negative 9y plus 2. Can everybody do that one? Okay. And then this one is the hardest one you've got to do. Most of you, a bunch of you probably have x cubed minus 27. We now know that's wrong, correct? What is this really? It's x minus 3 times x minus 3 times x minus 3. Yes? Now, look at just that part. Can you do the little shortcut there? That is x squared. Negative 3 and negative 3 is negative 6x. Negative 3 times negative 3 is positive 9, right? But there's an x minus 3 out in front. Now, do we know how to deal with that? We do. We did it right here, yes? The x goes through first. and gets x cubed minus 6x squared plus 9x. Then the 3 goes through. Negative 3x squared, positive 18, negative 27. Does everybody understand why I line it up this way? Does everybody see that? So I can keep my x squareds together and my x's together, right? Then I just add it up. X cubed, negative 3 and negative 6 is negative 9, x squared. 9 and 18 is 27x minus 27. Okay? Okay. That's where we are, yes? Everyone is good? What's the next page say? Polynomial multiplication. And it says what? Assignment. Do that page. Right now, you can use your notes, you can talk to your neighbor. We're going to be marking it in 10 minutes. Go. Huh? What does that say? Meanwhile, I will be fixing this up right now. This assignment will not be part of the interim that you are getting today. It is the first thing after that. So, I will be coming around to see how much of this you have done. Yo.
Since you want to check my work,
I'm not. Go sit down.
can I talk to you after this?
Go sit down. All right. Oh, it's got to be turned on. Okay. Let's see. Who's feeling strong? Jimmy Brar! What's the answer to G? X squared plus 2x minus 35. You're darn tootin', Jimmy Brar. You can multiply polynomials. I like the cut of your jib, son. That means I like you. Now, you get worried about that because you're very concerned about my level of hatred for you, which, of course, doesn't exist, but according to you, it does. Because you and Hitler, and I hate Hitler, so you're so bad you must be up that high, right? Yeah. See, you're not even on the scale. Don't worry about it. H. Who's doing H for me? Who's feeling strong? Loveline, you're feeling strong. What's H? 6x cubed.
Plus 9x squared.
9x squared.
Negative 10x.
-10x.
Negative
-15. Woo! Boy, you should sit back, Indeed. She's on fire. Look out. Who's doing I? Nobody? No tough guys? Nobody? Nobody? Sevic, hit me. 28x squared, yes. Plus xy, yes. Yes. Woo! Carrot, good thing you got your hood on. He's burning up too. Boy, Trinity, you should sit over by Sevic, then you won't be cold because he's on fire today. Whew! All right, who's doing J? Who's doing J? Nothing I like more than people who volunteer other people. Jazz, who's doing J? J for Jazz, go. No, the other Jazz. Yeah, you, go. 9x squared plus 12x plus 4. Whoo, doggy! He on fire too. Uh-oh. Now we separate the goats from the sheep. Which means nothing. You're just not allowed to say things like, I separate the men from the boys anymore, because that's not allowed. So, who can do K? Don't all jump forward at once. Oh, you're just... I thought you were hiding your face, so I didn't pick you. And then you fixed it. But when I said, who's doing K? I looked right, you went, boom. Like an ostrich. Well, I can't see you. We're Jeshin. Oh, no. Because kids, right? Babies, so stupid. Peekaboo. Yeah, you're gone, really. Baby, don't be dumb. I wish it worked that well. All right, so this is, of course, this takes 2 steps, right? So I like to leave the 2x minus 5, but then I multiply this one out to get 4x squared minus 10x. Minus 10x is minus 20x plus 25. Then I run this through to get 8x cubed minus 40x squared plus 50x minus 20x squared plus 100x minus 125 to get a total answer of 8x cubed minus 60x squared plus 150x minus 125. And then this one, of course, same thing. Boom, boom, boom. 2x cubed minus 4x squared y plus 3xy squared. Then the other one, plus 2x squared y minus 4xy squared plus 3y cubed. And then you add it all up and get 2x cubed minus 2x squared y minus xy squared plus 3y cubed. And all of these are worth 1, making that page out of 2, 4, 6. Oh, there's 2 more. Crazy Myers. Now, this one's tricky. Why is this one tricky? Because it's really 2 terms, right? Or 3 terms. So that is 8x cubed y cubed minus 4x squared y cubed plus 2x done. And this one, there's 3 of them again, is 12x to the 7th y to the 8th minus 28x to the 6th y to the 6th plus 32x x to the 3, y to the 8th. Making that whole page out of 14 because everything's worth 1. Any mistake gets you half a mark. It's not out of 4. Oh, right. I'm looking at the letter N. And N is the 14th letter. There's only 8. It's out of 8. There we go. Math guy can't count. It's because there's letters. My friend, the English teacher, gave me a little button that says, and then the devil said, put the alphabet in math. Get it? Because once you put letters in math, it gets confusing. Garlene gets it. Bonus points for you, Garlene. All right. 1251. Turn the page over. All righty. Please notice the title of the section on page 125. The title of the section. Huh? What? You guys don't have the same font? Well, that's too bad. What do you guys have? Well, that's kind of boring. Let me see that. That's crap. I like mine. Oh, well. The title is, of course, Factoring Polynomials. We have already done some factoring, haven't we? In what unit? The last unit, the radicals unit. And we're doing polynomials right now. So we already know what both those things mean. So now all we got to do is put them together. Factoring was when we found the numbers that multiplied together. Right? So we remember 45, we broke down, we found out that it equaled 3 squared times 5. Right? 3 squared and 5, these are factors because they are things that multiply together. Right? 45, that's the product. When you multiply two factors, you get a product. So here I have polynomials, don't I? I have a monomial 4 and a binomial x minus 5. So polynomials are right there, correct? Now, what have I highlighted in blue? Is that a product or is that factors? That is factors because this is saying factor 1, which in this case equals 4, is multiplying by factor 2, which in this case is x minus 5. Everyone agree? Yeah? Now, what then is our product here? 4x minus 20. Does everybody understand? Huh? Okay, we've just done 4 pages of this. Everybody should have been able to do this. Everybody good? Okay, now, what math did we do when we had a product and we're looking for factors? We did division, right? Because we're reversing multiplication, correct? So in this case, if this is my product and I want to find the factors, I must have to divide, right? Now, you people are intelligent people. If I wanted to use this bad word, But if I had this, 20 over 36, would you ever leave that as a fraction? No, you would simplify it, correct? How? You would divide them by 2 to get 10 over 18. Then what? Divide by 2 again to get 5 over 9. And you stop there, yes? What did you have to remember to do? If you did something to that, you had to do what to this? Same thing. So because I had two different things here, and I had to divide both of them, and I had to divide by the same thing, that principle carries on all the way through math. So here I have two terms, don't I? If I want to simplify those terms, just like if I want to simplify these terms, I must need to divide by something, yes? And because they're both in the same polynomial, just like these are both in the same fraction, I must have to divide by the same thing, right? So I have to divide by a number that works with both of these terms. What is that number? 4. If I divide that by 4 and I divide that by 4, I get x minus 5, right? And all of that is multiplied by 4. This is what we call factoring. Now, this is the easiest kind of factoring. All right? We are going to learn 4 methods of factoring this semester. Grade 9s have probably never seen it. Grade 10s will have seen it. But I guarantee you, I will teach you a new way of doing one of them that will be infinitely easier than what you already know. Okay? Okay. Let's look at this one. Is this factors or is it a product? It's factors. So I got to find the product, which means, is that letter and letter? So can I use my shortcut? I could. So it's going to be x squared plus 6x plus 8, right? Now, you are going to learn, grade 9s, you won't have seen it before, grade 10s, you already know how to do it. You are going to learn how to turn this back into this. Okay? But before we go on, I want to talk about this sentence. Factor 12. Now, in the last unit, when I said factor something, it meant prime factors, right? So factoring 12 meant, this is in our unit 3. That would have meant 2 times 2 times 3, right? 4 times 3. In this unit, factoring means find only pairs of factors. So, all the pairs of numbers that multiply to 12. 1 and 12. Because 1 times 12 is 12. What's the next one? 2 and 6. And what's the next one? 3 and 4. Are there any others? No. This is what this unit means. Is everybody good? Yeah? All right. So tell me then, if you really understand, factor 20 for me. And once again, you should be noticing that if you know your times tables, this is really easy. 1 and 20, 2 and 10, not 3, 4 and 5. Everybody good? Everybody feels I can do it, right? Okay. Factor this. I am not even going to make you do it with algebra tiles because I don't care. But I do want you to be able to do it with numbers. So 6x plus 3. If it is going to factor, that means it's going to break down into simpler things, yes? And if we are going to break it down into simpler things, just as if we were breaking down a fraction into simpler things, we must divide by the number that works with both of them. What is that number? 3. So I'm going to divide that by 3, and I'm going to divide that by 3. And I'm going to get 2x plus 1, right? Now, to get back to here, that 2x plus 1 would have to multiply by 3. Can everybody do this? It's pretty easy, right? Now, I'm going to write 2 different ones here. Don't do them. Just tell me if they're possible. Everybody ready? Is one of them, neither of them, or both of them possible? One of them is possible. Which one? A or B? B, because 4 goes into both of them. Is everybody good? Yeah? Okay. What about... No, that's fine. Turn the page over. Again, I am skipping algebra tiles. 4x squared plus 6x. If it's going to get simpler, I must deal with my numbers, yes? What is the number that will work here? 2. So that is going to get me 2 times 2x squared plus 3x. Am I done? Can I make it simpler? What do you notice there and there? When I had 4 and 6, you all saw I could take a 2 out because 2 was common. What's common now? So what could I bring out? An x. Because 2 and 3 can't work. So I also bring out an x. 2x. And that leaves in there what? 2x plus 3. Does everybody understand? It's exactly the same principle as the square root of 9x cubed, right? We took out the square root of 9. We took out as many x's as we could, and we left any x's under there. Does everybody understand? Okay. If this was the regular school year, we would work with this right now. We're not going to. We're going to turn the page over to page 127, please. This is the first type of factoring. All of you actually already know how to do this. You just didn't know it was called factoring. Well, all the grade 10s will have. The greatest common factoring, this, and please, ladies and gentlemen, write down what I'm about to write, capitalize it, underline it, highlight it, put a big Mrs. Bad Crumble cloud around it. What I am about to write, make sure you commit this to your memory. Do this first. If you can. If the question will allow you to do what I'm about to show you, do it first. Clear? Here are the steps. 1. Decide if the terms will get simpler. If they will, you go on to step 2, which is choose the combo of numbers and letters that work with all terms. This is your GCF. Step 3, divide all terms by the GCF. Step 4, write your answer like this. GCF bracket and then quotient 1, the first division you did, plus or minus quotient 2, plus or minus quotient n, up till the n that you're done. That might not make a lot of sense to you, but it will in a moment. Look at this very first question. Is that going to get any simpler? That is step 1. Does it? Yes. So, step 2, choose the combination of letters, numbers and letters that will work. Well, I've only got one letter, so can I worry about letters? No, I'm only worrying about numbers. What is the number that will work with 5 and 5? 5. So my GCF here, GCF equals 5. That's step 2. Step 3, divide all the terms by the GCF. 5x plus 5. Divide by 5, divide by 5. Step 4, write the answer as follows. GCF first. What was my GCF? 5. Bracket. What is my first division? X, because 5 and 5 cancels. Plus, what is my second division? 1. Done. Does everybody understand? Great. You do the next one. What's the GCF? 3. Divide everything by the GCF. Write it out. GCF first, then your answers. 2x plus 1. Is everyone good? Now listen to me and listen to me closely. Is there ever going to be a reason to hand in a wrong answer in this unit? No. Why? Because can I check that? Is 5 times x and 5 times 1 5x plus 5? So there is no reason to hand in the wrong answer. If that doesn't equal 5x plus 5, I've done something wrong and I better fix it, right? What's this one? What's my GCF? 3. So I divide everything by 3. I write the answer as GCF first, 3, and then all my quotients. What's this one? X squared. What's this one? Plus 4x. What's this one? Minus 2. And lastly, what is my GCF? Look again. GCF equals 2x this time, because there's an x and an x. So, 2x, and what is my answers? What's this one? 2x plus 3. Can everybody do it? What do you have to know to be able to do it? You have to be able to do division. And you have to know your exponent laws, don't you? Because if you don't do the exponents right, you're going to screw this up. Everybody good? Yo. Because this 6 has no x, so there is no common letter. Is everybody good? We are going to do all 4 of these together because the next page has the work you're going to do. What is the... First, I decide, is this going to work? Yep. Then I decide on my letters and my numbers. What number do I need? What number works with 25, 15, and 30? 5. What letter works with all 3? X. How many x's? 1, because this guy only has 1 to give, right? So it's 5x, 5x. Then I write out the answer. GCF first, 5x, and then all of my answers. What's this first one? 5y. 25 divided by 5, x's cancel. Plus, what's this one? 3x. 15 divided by 5, 1 of the x's cancels. Minus 6x y squared, because there's no y on the bottom. Still.
If the 25x had a 2, that would be x2.
Then I would have an x squared out here. All right. Look at B. Is it going to work? We always check, don't we? Because we're supposed to do this first. So let's check. Well, 8, 10, and 6. Oh, there's a number that's going to work. What is it? 2. A, nothing. So is any letter going to work? So it's just 2. 2, 2, 2. So what goes out in front? 2, then our brackets. What is it? 4 plus 5a plus 3a squared. Easy peasy lemon squeezy, right? Now, C is tricky. Because GCF stands for what? Greatest common factor. And it is 99 times out of 100 the greatest common factor. This is the only time that it isn't. Here is what I mean. What number goes into all of them? 5. Any letters? C and D. How many C's and D's? Just 1. Now, observe. 5 is the greatest common factor, isn't it? But what do you see there, there, and there? They all share a negative. Math people like that negative to come out as well. Everybody understand? So if it's all negative, this is that one time in 100 that you don't take the greatest common factor, you also bring the negative. Oops. Negative, negative, negative. Because negative 5 is less than 5, isn't it? It's not the greatest common factor, is it? So in this case, you want to bring that negative with you. So it's negative 5CD, and what's this going to be? 4C cubed. Then what? Plus 6C squared D plus 5. Done. That's the tricky one. Does everybody see it? Now, what about D? It stays the same. Why? Because there's no number that works, and there's no letter that works. So this guy is, we say, does not factor. You can abbreviate it as DNF. Everybody good? All right, it's 112. Listen to me. Your homework for the weekend is page 128. That's it. And prepare for your test. I'm going to do a couple of things right now that will take us to the end of the day. Sahil, what did you get on Unit 1 review? That's Unit 2. Hurry up. Right there. That's it.
Wait, what was it out of?
29. Okay. You're about to get an interim. Go sit down. You're not having a quiz.
Can I go to here?
Yep. Yep. All right. We're done for the day. Eyes up at the